let me carry on teaching you guys how to draw complicated graphs. So let's say you've got this line here, y equals x to the power 3 plus x squared minus 5. Now, how do you draw this graph here? Well, uh, break it up like this. So you've got one block here, and you've got so concentrate on these two terms. Now, if you try to draw this graph, it will look something like this. When x, let's investigate what happens when x is small. Now let's say x is 0.05, say it could be anything small. So around this region here, when x is small. Okay, let's see which term would dominate. So let's put 0.5 into this thing here. So here we've got 0.05 times 0.05 times 0.05. Let me get my calculator out. So clear this. So it's 0.05 times 0.05 times 0.05 equals. So this x to the power 3 will be this. Hang on. Will be x to the power 3 will be 0.00, what was it? 0.125. Okay. Now put this thing into x squared. So 0.00. Hang on. Let me just do it on a calculator. So we've got 0.05 times by itself once. So this here becomes that, and then we've got to add. We've got to take away 5. So take away 5 equals this. Equals minus 4.9 something. What was it? 9975. So my point is that when x is small, so around this region somewhere, this term here is this here, which is really nothing in comparison to this term here. By the way, this is negative 4 point blah 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 blah. Okay. My point is that when x is small, this x to the power 3 is nothing in comparison to this term here. So it tends to follow this term here. Yes, we could break it. We could actually forget about this term x squared as well. But why not combine it with a 5? Because we are pretty good at drawing x squared plus 5 or minus 5 or plus 3. My point is that we are good at drawing this. So by merging this x squared with the 5, we will get a more accurate answer rather than just looking at the 5. Because in this case here, if you put 0.5 into x to the power 3 and x squared, really these two terms will vanish in effect. But the reason why we merged it with this 5 here is because, okay, it's irrelevant. It's not that important when x is small. But because we are pretty good at drawing x squared plus 5, so why not just merge it? It doesn't hurt our brain anymore. So why not just merge it? Okay, so hang on. Let me start again. It's getting messy. So y equals x to the power 3 plus x squared minus 5. So my point is that when x is small, this here will dominate. When x is big, if you get 9 and put it into here. Okay, so 999 to the power 3. So hang on. So what I'm trying to illustrate is that when x is big, this term here will dominate because look at this here. Hang on, calculator. Clear this. Now 999 times 999 times 999 equals this. Okay, equals it's going to be a big number, a really big number. Let's just say 997 million. Okay, let's just say around there. Okay, and look at this, 999 squared. Hang on, let me calculator. Now let's look at these two terms here. Clear. So it's 999 squared. Okay, equals this, and then minus 5. You see, the minus 5 at this stage here, the minus 5 is no longer important. When x is small, that minus 5 was really important. But when x is big, well, anyway, it's going to be less than a million, less than a million here. So my point here is that when x is really big, this number here is so much more important than this number here. So my point is, when x is really big, this is so much more important than this here. You notice that when x is really small, this 5 here is really important because this is 0.0000 something, and this is also 0.0000 something. And then the 5 is really important when x is small. When x is big, these two terms together, or they're not important in comparison to this term here. Okay, so wait there. So y hang on. So y equals x to the power 3 plus x squared minus 5. It will look something like this. When x is small, it wants to follow this personality here. So it will be x squared minus 5. So x squared minus 5. I'm going to guess somewhere around here. Okay, I'm going to draw it like this. So this will be minus 5 here. Okay. Now when x is big, it wants to do this. Hang on, it wants to do this. Bear with me. It wants to do this. It wants to do something like that. Okay. So when x is big, it wants to do something like this. Okay. So I'm now when x is big, I know it wants to do this here. But the thing is, around this region here, this overtakes it, so it will follow this curve when x is small. So now it's just a matter of joining up the now this bit here. There's going to be a curve because this is going up, and well, there's got to be a curve around here. I don't know if it's like this or if it's like this down here, but I'm just going to guess at this stage here. We're just going to guess roughly like that. So well, I'm going to guess it like this. It could go something like this, but well, I'm just going to guess like this. Okay. At the moment, you don't know what this bit looks like. You got to learn. When you're older, you will learn calculus. Okay. This will tell you exactly where the bend will be, but at our stage here, we're just going to guess like this. And the true graph when you plot it on a calculator, graph plotter, sorry, it will look like this. So our guess here, so when x is small, it wants to follow that x squared minus 5. So that's why our curve, there's a small curve there in effect. And then when x is big, it wants to do this. It basically wants to do that x to the power it wants to do x to the power 3. It wants to do this. But because you've got to take this into account. So our guess was quite close. What we got wrong was this bit here, and we guessed it to be something like this, or it was slightly higher, something like that. But at this stage here, we can only guess this thing here. Well, anyway, the true curve will look like this. In the next video, I will give you more examples.